Hey everyone, welcome to my channel where we dive into the most mind-bending scientific mysteries. Today we're tackling a topic that'll flip your view of the world. We live in a virtual reality, scientists' discoveries. What if our world is just code, like a video game, and we're its characters? This isn't sci-fi, it's a hypothesis backed by science. Let's dive in. What if the stars are pixels and physics is just algorithms? This idea traces back to antiquity. Around 380 BCE, Plato's allegory of the cave suggested we see only shadows of a truer world, hinting our senses perceive an illusion. In the 17th century, French philosopher René Descartes, in his 1641 Meditations on First Philosophy, imagined a deceptive genius manipulating our perceptions, making us believe in a false reality. Descartes doubted everything but his own thinking. I think, therefore I am, laying the groundwork for questioning reality. These ideas fuel the simulation hypothesis, the modern notion that our world is a computer model crafted by an advanced civilization or even our future selves. In 1969, German engineer Konrad Zuse, who built one of the first computers, Z3, published Calculating Space, proposing the universe as a vast computational process with space and time as discrete grids. His digital physics views particles as bits of data and natural laws as processing rules, a visionary leap that anticipated computer simulations. The 1999 film The Matrix, directed by the Wachowskis, popularized this. Neo awakens to find he's in a virtual simulation controlled by machines. But The Matrix isn't just entertainment. It reflects philosophical debates, including Jean Baudrillard's ideas on hyperreality. The real breakthrough came in 2003 when Swedish philosopher Nick Bostrom from Oxford University published Are You Living in a Computer Simulation? In Philosophical Quarterly. His trilemma is mind-blowing. Consider three scenarios. First, humanity never reaches the tech level to create realistic ancestor simulations. Second, advanced civilizations can but choose not to run them for ethical or practical reasons. Third, if the first two are false, we're almost certainly in a simulation, as billions or trillions of virtual worlds could exist for every base reality. Bostrom calculates, if a post-human civilization runs even 10 to the 20 simulations, the odds of being in base reality are 1 in 10 to the 20. He points to tech progress. 1970s games like Pong were basic, but today's Grand Theft Auto builds cities with millions of details. In centuries, simulations could be indistinguishable from reality. Australian neurophilosopher David Chalmers, in books like The Conscious Mind, 1996, adds depth. If consciousness is a computational process, like software, it can be simulated. Chalmers sees the simulation hypothesis as a metaphysical possibility. Our world might be one layer in a nested hierarchy of simulations. American robotics expert Hans Moravec, in his 1988 Mind Children, suggested future humans will digitize consciousness, uploading minds to supercomputers to create virtual worlds for experiments or entertainment. If such tech is inevitable, we're likely already in one of those worlds. Quantum mechanics adds intrigue. The double-slit experiment, first conducted by Thomas Young in 1801, but interpreted in its quantum form by Niels Bohr and Werner Heisenberg in the 1920s, showed electrons act as waves, creating interference patterns until observed. Then they collapse into particles. This observer effect implies reality isn't fixed, but shaped by measurement. In the 1970s, American physicist John Wheeler coined the participatory universe. Without a conscious observer, the cosmos lacks definite form. This fits a simulation, like a video game, rendering only what the player sees to save processing power. Billionaire Elon Musk, inspired by Bostrom, said in 2016 the odds we're in base reality are 1 in billions. Astrophysicist Neil deGrasse Tyson estimates a 50-50 chance, citing tech's rapid growth. Now let's explore recent evidence making the hypothesis even more compelling. In 2023, British physicist Melvin Vopson from the University of Portsmouth proposed the second law of infodynamics, a rule akin to thermodynamics' second law, but for information, in closed systems, information minimizes, compressing efficiently. Analyzing thousands of systems, Vopson found that digital data, genetic sequences, and atomic structures optimize information. For instance, mutations in viruses like SARS-CoV-2 don't happen randomly, but reduce the code of DNA or RNA, like a file compressed into a zip. This challenges Darwin's random evolution, but explains biology as an efficient computational process. Why does this suggest a simulation? In a real world, entropy disorder grows chaotically, but in a virtual one, a programmer compresses data to save computational resources. Vopson sees this optimization in cosmic symmetries, like particle physics laws and biology. Genomes are strikingly compact. His AIP Advances paper links mutations to code optimization, hinting the universe is a compressed file run by an external processor. American string theorist Brian Greene, in his 2020 book, Until the End of Time, suggests testing for glitches or artifacts in reality, like inconsistencies in physics at tiny or cosmic scales. British physicist Stephen Wolfram, in A New Kind of Science, 2002, models the universe as a cellular automaton, a grid of cells evolving by simple rules, generating complexity, like John Conway's 1970 Game of Life. If reality is such a computation, it's simulatable on a computer. Israeli physicist Zohar Ringel from Oxford searches for digital signatures in the cosmic microwave background, Big Bang's afterglow. Regular patterns like pixel grids or rendering artifacts could point to a simulation. In 2012, physicists Silas Bean, Zorae Davudi, and Martin Savage from the University of Washington, in a European Physical Journal paper, proposed testing spaces discreteness. If the universe is a grid with a minimum cell size, like the Planck length, 10 to the minus 35 meters, high-energy cosmic rays should show anisotropy, uneven spreading, as if hitting a simulation's resolution limit. Experiments with telescopes like the Pierre Auger Observatory haven't found such anomalies yet, but the hypothesis persists. Nobel laureate Frank Wilczek notes in his work on physics beauty, the universe's laws are too elegant and symmetric, like meticulously written code without excess complexity. Another clue is the fine-tuning of constants. The cosmological constant, driving cosmic expansion, is perfectly tuned for galaxies and life. Tweak it by 10 to the power of negative 120, and everything collapses or flies apart. This fine-tuning suggests a design simulation, with a programmer adjusting parameters. Quantum entanglement, where particles instantly affect each other across vast distances, defies Einstein's locality and resembles a game server syncing data globally. Critics push back. German physicist Sabine Hossenfelder, in her 2018 Lost in Math, calls the hypothesis pseudoscience. It's unfalsifiable, like claiming an invisible dragon lives in your garage. No test can disprove it. South African cosmologist George Ellis argues simulating a universe with 10 to the 80 particles is technically impossible, even for a super civilization, due to exponential complexity. Brazilian astrophysicist Marcelo Gleiser questions why anyone would expend vast resources to simulate 8 billion characters. Yet even critics admit the hypothesis sparks new questions about reality and drives experimental innovation. The implications are profound. Economist Robin Hanson, in his essay, How to Live in a Simulation, advises living vividly. Simulation owners might shut down a boring script, like closing a dull game. Philosopher Preston Green warns against hunting glitches too aggressively, lest we crash the system. But there are upsides. The hypothesis could explain mysteries like dark energy, a code glitch causing cosmic acceleration, or the Big Bang, the program's boot up. The future is already here. Elon Musk's Neuralink tests brain-computer implants, a step toward digitizing consciousness and creating nested simulations. Futurist Ray Kurzweil predicts that by the 2030s, AI will hit singularity and will launch our own virtual worlds. If we're in a virtual reality, it's not scary, it's inspiring. We're part of an infinite, multifaceted code, where reality's boundaries blur, opening new horizons for exploration and creativity. Thanks, friends, for joining me. If this video sparked your curiosity, hit the like button, subscribe, and share in the comments. Do you believe we're in a simulation? See you next time. Keep exploring reality.